All right, welcome everyone. Thank you all for staying down here for the quite exciting and interesting topic of transparency, which hopefully will be more transparent than those accessible upstairs. Yeah, that was for Dove. All right, so we're going to start this morning with Sebastian Holder, who is going to introduce us to the PDF transparency model. So go for it.
Thank you. So welcome everyone. My name and the company I come from, you can read here. A special welcome to the people listening to the stream. Hello to my colleagues back at home. Right. So transparency, I think that's a pretty important topic. And I think the spec thinks the same. There's a whole chapter on transparency. It's chapter 11. And additionally, it's woven throughout all the rest of the spec. So I think it's pretty important to consider that today. Here's what we're going to cover. That's the whole mathematics behind it. No, we're not going to. We're not going to end up like him. So actually, we're going to do this. First of all, think about what transparency is. And I'm going to take a more visual approach to the whole thing. So I'm showing you a lot of examples, also real-world examples, which I've dug up somewhere in the World Wide Web. And the last point here, consequences, is more about what it means for people who implement PDF readers or writers. So that's more, leads us to the discussion part. Anyway, let's get started. What is transparency? Here are some real-world transparent objects. Sunglasses. That's a solid object, the glass. And yet you can look through it, so it's not completely opaque. There's one kind of transparency. There's another kind here, completely different, a fly screen. This is a material which is totally opaque. And you can still see through it because there's holes in between. So two kinds of transparency that we have. And PDF differentiates between those two. So you have two options. And of course, you can also combine those two. We could create a fly screen out of transparent material. Totally possible. Now, as I said, both are available in PDF. The first one is called opacity, something which is solid and you can see through it. And the other one is called shape, because the shape is not completely there. And combining both leads us to alpha. Someone made up the term alpha, I guess Duff and Porter back in 1984. They just turned it that way. So if you multiply opacity and shape, you get alpha. Here's a PDF example. We have two circles. This one is opaque. This one is halfway transparent, say 70%. I don't know the exact number I've used. Anyway, let's try to zoom into this a little. And we see pixels. I hope you can see them on the screen. I guess you can. That's a rendering of these vector objects. Eventually, I have to render pixels at some point. And I want to look with you at 4 of these pixels. Here's the first one. It's in the left object, and as I said, this object is totally opaque. So this pixel has an alpha value of 100%, totally opaque. This one here in the right object is 70% opaque, as I already said, because the opacity value of this object is 70%. But now comes the interesting part. What about this pixel over here? Now theoretically, since I said this is a vector object, this pixel would be half filled. So it's not completely opaque, even though this is a opaque object. So this pixel is half filled, so 50% alpha, 50% shape.
But is it actually alpha, or is it just a color change for anti-aliasing? If that's anti-aliasing, that's not transparency.
That is anti-aliasing, that is true. So it is a color change, but where does this color change come from? It comes from the fact that this pixel is only half filled.
No,
so
it takes the color
so
value,
the rendering...
It's taking the color value and changing the color value. It's not actually applying an opacity to it. There's a difference. The pixel is fully filled, but it's fully filled with 50% of the value of the color of the full object.
Which is the rendered result, yes.
But you will not see the underlying
Right.
color.
Exactly.
Yeah.
Right. You wouldn't, if there was something underneath that, you wouldn't see anything underneath it.
It would blend.
No.
No, it doesn't blend because it's
No.
anti-aliasing.
If you turn off anti-aliasing on your monitor, then it's going
Then it doesn't blend. That's true.
So it's not a transparent object in your PDF. It's only a thing on your monitor, because Adobe has chosen to turn
To
on
anti-alias.
in
Yes.
case of transparency. Flatten transparency is a really bad idea. But this is not transparency.
Right. It's anti-aliasing.
And anti-aliasing has to be treated as shape values. That's what the spec says.
Anti-aliasing is outside the spec. Yeah, there's nothing but anti-aliasing. I mean, I have to double check, but I'm pretty sure we never mentioned it because it's out of scope.
Okay, so
That's not,
we'll leave that open.
that's not really true.
Yay! Right into discussion.
The spec mentions that anti-aliasing, I know it because I've implemented it.
Right.
The spec mentions that anti-aliasing has to be done using different shape values, but not opacity values. And
Yeah.
this sentence is in the spec.
So that's what I knew as well. But we can also choose to somehow see this whole thing a bit differently, and we could choose to see a gradient right here. Okay, so that's kind of my way of getting out of the whole thing. Let's leave this discussion for the break time. Should we? Here's a confused guy. That's because I was confused right now. The reason why he is here is the rendering of opacity and shape. I've gone back one slide. Can be approximately the same because we have only pixels. So we can end up with the same pixel representation of a shape value of 50% and an opacity value of 50%. So why do we have to make a difference? That's what he actually is thinking about. In most cases, we don't have to, and we can simply use alpha in the computations. But there are a couple of special cases in which we need to take shape and opacity as being different from each other. And that has to go into the math on different parts. Okay, so already some discussion about what is transparency. We're going to move on and going to think about how to combine two transparent objects. Only two for now, more later on. And here is an example of two objects. We've got a rectangle in the background and a green circle in the foreground. The rectangle is red and has an alpha value of 50%. And here's the green circle and alpha value of 70%. Now, at the part in the middle, these two blend with each other. So you kind of just take both of the color values and mix them together depending on the alphas they have. You take two colors, you get a resulting color from that, and that is a color weighted by the alpha values you've got in there. So basically you take coffee and milk, you stir, and you've got decent coffee. However, once you come to your favorite coffee shop, you realize, wow, there's all sorts of additional flavors available. You can put in some caramel and some vanilla, whatever you like. And the same is available in PDF. The flavors are called blend modes. And these are flavors for blending two colors. A blend mode, here's what it does. It also gets two colors as input. And out comes one blended color. The blend mode is just a mathematical function, and there's 16 different ones, and they all lead to some color in the end. So the whole way of combining two objects is you have three colors and actually weigh these and get the resulting color. Now, the picture I've shown you before had blend mode normal, which is the default blend mode, and it doesn't do much. It's identity transform in here. So what I said before was true because the math just collapses to the simple case of adding two colors with it, or multiplying two colors with their alpha values and then adding them up. Here's another blend mode. I've set this circle to blend mode overlay, and there's now a different color in here. You might not know now because the other slide is a few slides back, but here's yet another one, color burn, and you've seen that this red part has become darker. I'll go back once. That's overlay, and here's color burn again. But there's another one which is completely different, and suddenly this part here turns green. That's the saturation mode. What it does, it takes the backdrop's saturation and combines it with the luminosity and color of the foreground object, which is this object. Foreground object is called source, actually, the source object. Here's the backdrop. So there's all kinds of different blend modes available, as I said, and I promised you real-world examples. What can I do with these blend modes? Why are they there? Here's a picture of green meadows. Well, regretfully, the photographer has chosen to take a black and white picture. Might be a good idea for photography's sake, but I want green meadows. So let's put a green rectangle over this whole thing. I've put some transparency to it, and this has blend mode normal. Doesn't look very interesting. How about blend mode color, which is specialized in these kinds of things? And suddenly you have actually green meadows, because color takes the color of the foreground object and combines it with the backdrop's luminosity and saturation. So these are some ways of blending two objects. Blend mode is the one thing. There's also something else. Whoever said that two objects have to blend with each other at all? There's also the option to let objects knock out each other. What does that mean? I have the same example again. Here's the blend mode color burn we've already seen. Now if I set that to knock out, the top object knocks out anything underneath it. This circle still has the same blend mode and the same opacity and therefore alpha values, but it knocks out what is underneath. So you can't see the effect of blending two things because nothing blends. There's nothing underneath anymore. Here's a kind of cheesy thing to help you remember what how this works, because the only thing that knocks out, and here the difference comes in again, is opacity. And you remember how we said the guy wears sunglasses? Opacity, sunglasses is an example for that. Only, it's kind of cheesy, I know. Only opacity knocks out, shape doesn't. And that's an important thing to remember for us. Shape values do not knock out. The knockout effect is only produced for opacity values. Why is that the case? Here I've added a shadow to this circle. Now, all kinds of gradients in PDF are defined as having shape values or varying shape values when it comes to transparency. And this is why this works here. So if the shadow were defined as opacity as well, we would have an effect something like this. It's a fake, I know. But there would be a knockout effect on the whole thing, and we would see through to the backdrop of the, we would see through to the paper color, which is white. So we got to remember only opacity values knock out, not shape values. And here we're back to anti-aliasing, because we are not allowed to let anti-aliasing pixels knock out what is underneath. because that might result in artifacts. So if we have two very different colors from each other, we would have white pixels in here. Might be seen, might not be, but might as well be. Okay, so these are the main options we have for combining two objects, and we can take that to the next dimension by combining three or more even. And I've got another example here. We've already seen two objects of these. I've added on top of that a triangle and a star. So we have four objects combining with each other. How does that work? We're in for some interactivity, and we're going to see how this works. Let's see. Yeah. These are the four objects on top of each other. Now, the first, second, and third blend with what is already there, and we've got the result. So you take two objects that you have and blend them with each other. The result of that is blended with the third one, and the result of that is blended with the fourth one. So this whole process goes on, and in the end we get one resulting picture. There's another ingredient to this whole idea of blending multiple objects, because so far it's been quite easy. There's a possibility to add transparency groups. Now, what is a transparency groups? Here's a screenshot from the example we've just seen. Let's say we take the second and third of these two objects and put them into a transparency group. We group them. What does that do? It means when rendering, as soon as we come to the transparency group, we lay aside what we've rendered so far. Just keep that somewhere. And now start anew by rendering a transparency group. We start with an empty surface. In one case, for those who already know, in the isolated case, we start with an empty surface and render those two objects in that case, the middle two, on that surface. And the result of that is then combined with what has been there already. And on top of that, the fourth object is combined. So here's the first one out of the transparency group. Now we lay that aside, start the transparency group, add together the two elements in it, and here's a basically the result of that. And this is added with the first object, and now the fourth comes to that all. And we've got the resulting image. Now, this is all nice and good, but you might think, why should I use transparency groups? Because I haven't told you any real advantage of this whole thing. So you might think, well, it's not worth doing that. It is, because here's one reason. Transparency groups support blend modes. So once you're done with having a whole transparency group rendered, you can then combine it with what is already there using one of the blend modes I've already shown you. So there's clearly an advantage here. There's a few other things to know about transparency groups. They can be nested. You can have a transparency group within a transparency group, so that can go to, well, virtually any depth, or pretty deep at least. And in fact, anything you do in the transparent imaging model takes place within a transparency group, because by definition, what you composite on a page is part of the so-called page group. And the page group is a transparency group. So you always nest once you have the second group already. So by definition, there's always one. Transparency groups have two options. And I've told you about what knockout does in the combination of two objects. Now, it's important to know that knockout is defined in PDF as an option of a transparency group. So while blend modes are something that is pushed on the rendering state, and the blend mode stays in effect until you push another one there. A knockout group, the knockout setting is always set for a transparency group. So that's a distinction here. And once you set knockout, all the objects within that transparency group will knock out one another. So the topmost wins out of these.
Wait, if the knockout is set on the group, the knockout applies when you're blending that group back into the main page. It doesn't apply to the blending of the objects in the group.
When knockout is set on a group,
If you have a group marked as knockout,
yep.
that doesn't mean use knockout for all of the objects in the group. It means when you composite the group back to the main page, knock it out.
No, that would be the setting of the outer group.
It's about the behavior of the elements inside the group. There's a pretty good picture in the documentation of Adobe.
No, 'cause the same
Yeah.
thing is true for blend, no, because it also applies to blend mode. The blend mode for the group is how you composite the group back to the main page.
Exactly, but there can be a blend mode for compositing the group into the main page, and there can be a blend mode for compositing the objects within the group. And
Right.
the same is true for knockout. Knockout setting on a group counts for the objects in the group, and knockout for the outer group, which can be the page group, counts for compositing the group inside this outer group.
The other group.
Okay, that was the knockout parameter. There's a second one, isolation. And let's see, yeah. Isolation is about how a group interacts with the outer group it is composited into. So what I've shown you in the example before was actually an isolated group. So the isolation parameter was set to true. And that means when you start working in the group, so compositing the group objects, you start doing that with a completely transparent surface. And that's what I've shown you. However, if you set a group to non-isolated, you start compositing the group with what is already there. So you take the result of the computation so far into that group, start compositing into that, but then in the end you have to remove the influence of the outer group and then composite the result of that with the outer group. Why is that? You can apply a different blend mode. So the results that what came into from the outer group has to be removed first. You technically don't have to remove it if you use blend mode normal. So that's a shortcut you can take. But you have to remove the influence of the outer group objects. Cool. Okay, real world example. Pretty creepy picture which I found. But this is a website, and they had a Adobe Illustrator file which has all kinds of transparency objects, transparency effects in them. And I've taken this apart a little, and I'm going to show you something of what I've just described within that picture. So I'm removing some stuff now, and here's just a guy sitting on the bench. And what the person who has produced this illustration has done, the trousers down here don't actually have the shape you see here. Instead, they form a transparency knockout group with the rest of the clothes. And if you remove the transparency knockout, the knockout setting, here's what there is. So this is the actual shape of the trousers. However, because the other surfaces are above it, the knockout is performed and you can't see the parts down here. So I'm going back once. That's how it should look like. And because of knockout, it looks that way. Without knockout, that's what it would be. And the same is true here at other parts of what he wears. Back again. Right, so that's how it should look like. Another thing that is in the picture, you see the bench here, and it's solid blue right now. What the person did is to apply a blend mode for that bench. It's blend mode multiply. Now you can see, even though the bench is still opaque, you take parts of what is underneath, the black lines here, and you can see them through. So that's what blend mode multiply does. It multiplies the color of backdrop and source. Okay, this is, I guess, pretty difficult to see with the projector. Here again, knockout is performed. You can see right now some parts of the dress down here, and it blends with the piano. Once you stick that into a knockout group, the blending effect here is removed because the piano, which is above the other things, knocks out what is underneath. Last part here, the creepy hair. It's solid blue, but there is also added a gradient in that. We can't see it because the blue part is above it. Now, what the person has done is add specify two different blend modes for the blue part and for the gradient, and out you get this. So the blue surface is combined with blend mode color, so it adds blue to anything that has been there already. And the other one, the gradient paint, is added with blend mode screen. That means it halfway removes the blue effect again. So there's all kinds of things you can come up with once you get into how these blend modes work on a basis of illustration, and you can do all kinds of things. So in my opinion, blend modes and transparency groups and all that have largely increased expressiveness of PDF when it comes to illustration purposes. So you can do all kinds of really cool things with it, and if you're an illustrator who is able to use all these things, you have lots of options. However, it has also introduced a lot of complexity, new requirements for people who want to implement PDF readers, and that's the last part which I would like to discuss with you. This kind of leads us into discussion because I thought we could try to gather that together, what the consequences are, what you think. I have written down what I think, so we can do that. Then we can have the general discussion. I guess there might be questions, and there's definitely lots of edge cases as well. And then I've got a goodie at the end. I've found another pretty impressive illustration which has a lot of transparency effects in them. I'm just going to show you this at the very end, and you can have a look at it and try to guess what's in there. It's not really clear from what I found, but nonetheless it's pretty impressive. So yeah, are any of you there who have already done an implementation of transparency? So perhaps some of you can say something about the added complexity. I know, yeah, what do you think? What is the complexity that's added when comparing the transparency model to the opaque rendering model? What do you have to implement? What do you have to do? What's the difficulties? There's lots, so.
I'm speechless.
Well, it's a pretty simple thing to mention. You have to implement 16 blend modes for one thing. So, what else is there?
But the algorithms there are all well defined. I think in terms of the transparency model, that's probably the least complex part.
True enough, yeah.
I'll just throw one out, which is that for people who had not chosen to do it before, one of the things that they're forced into doing and implementing transparency is support for color management.
Yeah. Yeah.
And for
I
a
haven't
lot
gone
of
into
people,
that
that's a
so
much bigger thing to swallow than a
Yeah.
lot of than the transparency parts itself.
True enough, yeah. Yeah. Any other ideas? I guess for some, well, we have a reader in Java, and we've yesterday already discussed that color and some things are pretty complex depending on which programming language and framework you're in. So transparency is the same problem in Java. You have several transparency channels now. You have shape and opacity. You have to add in those transparency groups and maybe refer back to what is already there when combining into the transparency groups. You have to add the knockout effect. So that's for some implementations a pretty big thing already, depending on what you have. I mean, if you have a C library which you have written on your own, and you can add as many color layers and transparency layers as you like to, perhaps that's not such big a deal. But for us in Java, it's definitely a big thing.
When you're rendering just purely in an opaque world, then you've got the luxury that once you've seen an object and handled it, you can just forget about it and move on.
Yeah.
Whereas when now you're working in a transparent world, you can never forget about what happened before.
Yeah.
You always have to take that into account, and that's to me that's the biggest consequence.
Yeah.
But it's only software, right? So.
Yeah, but still, there's memory requirements for that and added complexity. So yeah, that's another big thing.
There's obviously the conversion of PostScript, which doesn't have transparency.
You have to flatten. Also for printing, PCL, for example.
The issue we run into is not rendering, but color conversion. When
Yep.
you're converting from RGB to CMYK and you've used pixel selective transparency, that becomes a nightmare. Yeah.
Yeah.
You run the color through an ICC engine and retain it uniquely so that that is the only color that goes transparent.
Yeah. I think there's also some more in your presentation and about spot colors and device N and all that. So that's another thing which adds complexity, and we've talked about it yesterday in the color workshop, color session. Tint transform and all that. So.
We implemented the transparency as well, and I wasn't leading this project, so from what I know, we run into a lot of problems with performance, memory consumption, stuff like that, and also anti-aliasing. It's a major issue.
Yeah.
If you do anti-aliasing on objects as you render them, you cannot use that because the end result is something that is not acceptable again. So yeah, a lot of complexity in there, a lot of demands.
We also have to watch the fact that, especially if you've got files with blend modes, not blend modes, but blending color spaces other than RGB, the entire anti-aliasing algorithm system doesn't work the same way if you're dealing in a different color space, which most people have never encountered before either.
Yeah,
Right.
why we decided to run on the RGB, basically.
Yeah.
But if you've got a group that says, I need you to operate in CMYK, you have to, if you're following the rules, then that's...
Yeah. There's one thing I left out before, and now coming to that, lots of these blend modes are defined as working on the different components independently of each other. So for RGB, you blend red with red and green with green and so on. However, as you all know, RGB is additive and CMYK is subtractive. So the results of blending in RGB and CMYK are pretty different. So you have to implement the whole thing at least for RGB and CMYK, never to mention device N.
I believe spec says you can choose what color scheme you're going to use, and Adobe.
For the default, if one is not specified, you
Yeah,
can pick which one you
yes.
want. But if one's specified, you don't get to override that.
Yeah, exactly. That's what we do.
Yeah, everybody picks, for default, everybody picks RGB except us. Well, but it's interesting. There's a historical reason for that, and the historical reason is that when we implemented transparency, all of our apps that were generating it, Illustrator, InDesign, were all operating natively in CMYK by default because that's what all of the designers were using. So for consistency with what they saw at authoring time, it made perfect sense.
Yeah.
Nowadays, when you have Microsoft Office and all of these pages and whatever else authoring everything in RGB, and if they don't remember to put in the blend space, you get a very different result.
Yeah.
And it is an interesting, and or comparing two PDF implementations. Yeah, it's actually something we've been talking about recently. We've been talking about, and also ISO has been talking about. Is that something we should standardize more concretely in the future?
Okay.
Because it is creating discrepancies between render.
Well, standardizing it might bring some implementations into trouble. At this point. But anyway, go ahead.
I'm not saying ours is the way it should be standardized. I'm just saying it's an issue.
Yeah.
Listen, anytime there's a device, pick whichever way you want, that may not be the right thing to do.
Yeah. Please.
One more question. So,
Yeah.
you have different groups of landing and post spaces. You are just creating an off-screen pixmap and render to this background. And after you have closed rendering of this group, you use it as your own object to blend again with other stuff. Is it this way to imagine it?
That's the basic idea and how you can do it. There's some cases in which you can optimize the whole thing and don't actually have to render the group as all. Because the result would be the same as just rendering the objects on the page. That depends on the blend modes and how the group is composited with what has been there already. There might be further optimizations, but that's the basic idea. That you create an off-screen image first of all.
And it also depends whether you're rendering to screen or to print or to various other things. And you may, if you're rendering to screen, then you're going to pixels anyway, so bitmaps are fine. But if you're doing this on a printed device, you may keep everything vectorized for as long as possible. You may not actually generate the scans. And that's just optimization and implementation. There's nothing spec in that.
Yeah. But there's a lot of room for optimization, I guess. So. Right. Any other general questions? Because consequences, we've covered that quite a bit. Anything I haven't explained clearly enough, or anything you'd like to hear? We have 7 minutes. Yes, please.
One topic to mention is accuracy. If you have a large stack of X objects rendered into bitmaps, then 8-bit might not suffice 8 bits for blending.
Yeah. I think there was one mention in the note, I guess, in the spec that you should use as much accuracy as you have. I'm not sure if I've read that at this point. Yeah.
Are there any chance we can get links to a daily document and the other one? I think I'm going to spend weeks on that one alone, I suspect. So if they're available publicly.
Okay, you have nothing else to do, Mike.
You meant the visualizations?
Yeah.
I think
source documents.
I've usually got the links down here in very small print, so you can get these. Let's see, should be back there somewhere. And the other one is also online. Oh man. Here, yeah. So that's that comes from Layers magazine. Yeah. And the other one is, which I'm showing you later on, is on Dropbox. Or actually, I can show it right now. Watch Acrobat render. more to come. Here we go. Yeah, that's it, I think. So yeah, there's lots of gradients in them, lots of special effects here, so it's all blurry and stuff. But this is all vectors, okay? All vectors. Pretty crazy stuff. Yeah, a lot of blending around here, and obviously at the glass parts here. So pretty fascinating, in my opinion, just to see it from a standpoint of designing it. I guess that takes a lot of time. So yeah, that's available as well as an Illustrator file. So you can kind of look into it, but you can't see all the things. That's a bit annoying. You can't see all the objects and can't see exactly which blend mode and stuff has been used where. But I guess if you spend some time and dig into it or dig into the source code, the PDF code, you can figure out a lot of that. All right. So 3 minutes ahead of time. Any other question? Otherwise, there we go.